This video is sponsored by PCBWay. More on them later. Yeah, I reckon I should fix that. And that's precisely what I'm going to do in this video. Now, if you haven't watched part 15 of this series, where I explain at great length all the modifications and upgrades I'll do to this machine and why, I would highly appreciate if you did so instead of commenting the same questions I've already answered. If not, no big deal, comments help boost engagement. Just don't expect me to answer with more than a link to the video. Now, I have to come clean, aside from this, I haven't actually printed anything on this printer since doing the last video about it. Someone in the comments suggests a great solution to at least provisionally get rid of the constant layer shift in the x-axis by basically homing the axes after each layer, which, as opposed to clipper skew correction, would totally work, and I genuinely tried to do it. I reflashed the firmware and inserted a homing command for just the x-axis into the layer change Z code, but a problem I kept having was that in order to home the x-axis, the printer always raises the z-axis first, which is good in general, but in this case, with the slow retraction and the Bowden tube, it left a blob of filament on the corner of the print on every layer, messing things up pretty quickly, and I just couldn't figure out how to make it not lift the z-axis, so ultimately I just gave up on it. Since I'm now taking the entire thing apart again anyway to fix things in hardware, it just didn't seem worth the effort. So yeah, first step, break the entire printer down again to change out the V-groove rollers. Let's get cracking. Well, that's it mostly taken apart now. Disassembling things is always faster than assembling them. Took just about 3 hours to undo what I built over 6 months. Now, I need to replace my DIY single bearing V-groove wheels with ones that have 2 bearings each, and like I said in episode 15, the only reasonable way to go about this would be to install the W version of the popular POM rollers everyone likes to use, since those tiny, cheap, low-grade bearings also introduce a lot of runout. However, I really want to prove that it can be done with those wobbly eccentric bearings, so I'm going to once again make my own custom V-groove sleeves. The original ones I made out of HDPE bottle caps. After seeing them in action, I have to say, I feel like HDPE is a little bit too slippery and soft for that kind of application, so this time around I'll be using some scrap ABS. No idea if it suited any better though. After all, there is certainly a reason the real thing is made from a plastic called POM. Also, I'll just be making a single one as a proof of concept. Without a lathe, this inner rim for the bearings to butt up against is a lot of work to machine, as you'll see in a bit, and I really don't want to do that 16 times. 20 if I include some spares, so for all the other ones I cheated just a little bit and had them resin printed by our sponsor PCBWay. To start off, I first need to melt the ABS into a usable blank of material. Just like last time, I'm doing this with a hot air gun and disposable gloves over knitted wool ones to manipulate the molten plastic without burning my hands into oblivion. These are vinyl gloves rather than the latex ones I used previously, but as far as I could tell, that didn't seem to make a difference for this application. Then I just stuffed the agitated polymer pate into the wooden pill press die thingy I made earlier, and once again misused the poor old drill press by applying unreasonable amounts of pressure with the quill. But of course, real force still has to be applied with a clamp, so let's do that. This is my first time working with ABS, and I have to say, it's very interesting. For one, it really stinks up the place. Second, it seems very rubbery compared to HDPE when molten, although I guess that could also be due to the fact that I possibly wasn't able to fully melt it with the heat gun without burning the surface, because when I cut off the excess and looked at the cross section, I noticed it being full of tiny bubbles. So just in case that's no good, I made another blank from just plain old HDPE. To start machining, I made this kind of dedicated mounting chuck for the drill press where my compression molded blank goes into, and by tightening the 3 incline screws, it doesn't only grip onto the blank, but also tightly pulls it against the surface of the chuck. This gets mounted in the drill press, and I'm off facing the end. Now, my first impression of this ABS is that it generates awfully sticky swarf. I already did this step on the HDPE blank because the second time you do things, everything goes much more smoothly, so I'm showing you the allegedly better run on camera, but the HDPE was definitely a lot easier to work with. This ABS really doesn't cut very well at all. Anyway, then I'm creating a little center divot because the next step is to punch a hole right through the entire blank with this fortunately pretty new and sharp 7.5mm drill. What do you need a lathe for if you can abuse your drill press, right? To hold the drill bit straight, I literally just have it stuck in a piece of wood with small vice grips preventing it from spinning. While fun, that hole was really just the minor diameter of the internal profile, so now I need to machine out the first pocket for the actual bearing. And because I can't safely start the 10mm drill on a flat surface, I have to get the big hole going for it to follow, which I'm doing by switching back and forth between 2 equally unsuitable carving knives. This is where a boring bar in a lathe would work wonders, because if I overshoot the diameter of this hole, my bearing is gonna fall out. So once my 10mm pin barely fits, I do the same boring setup with the 10mm drill bit and push the hole to the required depth. Sticking in the pin, it looks like the hole came out pretty concentric. There's only a 1/10 or 2 of run out. This means I can take it out to finally have a closer look. Not gonna lie, the surface finish inside really isn't all that good. While it is a friction fit on the 10mm pin, the HDPE one I finished earlier turned out significantly better. In fact, like in my original video, the surface is so evenly colored, the camera has trouble properly picking up the geometry. Here's them side by side. I think HDPE was the better choice after all, at least for ease of manufacturing. Moving on, the 10mm pin now serves to spin the workpiece, so I can face the other side to dimension. And I already said it, but I'll complain about it again. This ABS is a pain in the butt to work with. While HDPE shavings tend to stick to everything too, thanks to electrostatic attraction, this doesn't even want to clear the tool, constantly getting sucked back in and spun around by the workpiece. And to top it off, because it's more brittle, those super fine strings of swarf like to disintegrate into basically almost dust. A true microplastics nightmare. Screw recycling, let me vacuum this up so it hopefully at least gets safely incinerated instead of spreading everywhere. So to find out if I've cut far enough because I can't get the calipers underneath the drill press, I'm using a piece of shaft and a spare extruder gear to probe the depth and lock it, which then allows me to take a measurement with the calipers. The dimension I'm going for here is from the end of the 10mm pin to the face I'm working on, which should be exactly 5mm. Then comes the fun of starting the counterbore for the second bearing. And of course I had to screw it up. This is too big. Fortunately, I'm only a millimeter or so in, with enough left to go for the drill bit to fix it if everything goes to plan. However, I can't go full depth with this either, because the centering tip of the drill bit hits the 10mm pin, so I have to carefully keep digging with those carving knives, despite the fact that I don't actually see what I'm doing at all with the camera in my face. Let's see if I ruin things yet. Uh-oh. That's not good. Oh no. But it's still not deep enough, so I have to keep going despite technically having ruined the part at this point. I say technically because there's still ways to salvage it. For example, by wrapping a layer of tape around the bearing, I could still install it with a light press fit like it's supposed to, but if I don't, well... Moving on, I can now make the other side of my back hurt as well in this comfortable 90-degree bend to turn down the outside diameter of the part to 19mm. This is fairly straightforward, and you can really see how disgusting of a mess this ABS makes. Then I can scribe lines into the part for the width of the wheel, as well as the center line that the V-groove has to get started on. The top section gets turned down to the minor diameter of 15mm. Fortunately, the V-groove itself is one of the easier steps. Using the V-groove cutting tool I still have from the original video, I can just feed it in perpendicular and at the right height, guided by a few pieces of wood on the drill press table. This should prevent getting the V-grooves all crooked, like I did when I manually machined the original wheels, aligning the tool by eye. Provided, of course, the cutting edge of the insert is at the correct angle to the tool itself, which I don't know. Measuring with the pins, I should be seeing 22.24mm here, and it looks like I overshot again. Great. Fortunately, this is not the final dimension. I need to rework that V-groove anyway, so I can cut the purely aesthetic chamfers on both sides. Here I'm using the carving knife pressed up against the blade to reduce chatter, because my tool is, unsurprisingly, nowhere near rigid enough for a machining operation like this in high-strength plastic. And that's about it. Here is the result. This is about 90% complete. The only operation left is to mill a few slots into this cylindrical section here to create a kind of drive dog, allowing me to spin the entire thing up on its own bearings. I'll get to that in a bit, but for these ones I'll skip it because I just can't be bothered. Of course, the HDPE one turned out a lot better by comparison. I pretty much hit all dimensions spot on but one, latter being the width of the inner rim for the bearings to bottom out on. I think it ended up more like 0.8mm wide instead of 1mm, although ultimately that's still a lot easier to work with than an oversized bearing pocket like I had on this one. As far as material quality goes, pressurizing the molten plastic before it solidified really helped against air bubbles. When I made my original V-groove sleeves, I had quite a few cavities in the plastic, but this time on the HDPE, I barely found any bubbles at all. Yes, the ABS is full of tiny ones, but on that one I did burn the surface with the heat gun because I seemingly couldn't get it hot enough to melt properly. As you can see, this is a heck of a lot of machining for a single 1mm lip inside the roller. It took me the better part of 2 days. Granted, using HDPE, which was a lot easier to machine, and without having to film everything, I think one roller could be done in less than an hour, maybe 20 minutes on an actual lathe. But at the end of the day, doing 16 of them still isn't the best use of my time, which is why I had the other ones resin printed by PCBWay. So let's unbox those and finally get on with the project. This is my first time getting parts resin printed by PCBWay, and I have to say, it's top notch. These V-rollers look fabulous, not least because I don't need to machine them now, and the step up in resolution from FDM printing is just chef's kiss. These hollow shafts, for example, I don't think you could have gotten a decent result on an FDM printer, even with a 0.2mm nozzle. These are just too small, and they need to be accurate. This logo is also resin printed despite looking like injection molded polystyrene, and it's pretty surprisingly transparent. Like, if I hold that up to the camera, you can see right through it, no problem. Anyway, enough talking, let's assemble it before I end up losing one of these. Now, as nice as these are, we're not done yet, because naturally no 3D printing technology is perfect, and a printed circle is still terribly jagged and orders of magnitude out of round compared to an actual turned part, so using these wheels as is would result in one heck of a rough ride, to say the least. And even if that wasn't an issue, bear in mind that my bearings themselves are inaccurate. The ID isn't concentric with the OD. You can actually even see this if I rotate them a bit. So if both my bearings wobble however the heck they please, the V-groove sleeve's obviously gonna do the exact same, thwarting all my efforts of getting the carriages to run straight in the first place. So in order to fix this, I need to spin the whole wheel up on those lopsided bearings and recut the groove. While that means the groove will be askew with respect to the ID of the sleeve, it'll actually run true in relation to the mounting hole of the entire wheel, which is exactly what we want. And that is what this drive dog spline thing is meant for. That worked surprisingly well, actually. At least in theory, this V-roller should now be running pretty much true, despite the individual bearings being less than perfect. Also, because it has 2 bearings, it's actually a lot more rigid than my original single bearing version. Honestly, I can't wait to see the printer in action with these upgrades. Now, I just need to do the same thing a couple more times, which, all things considered, shouldn't take as long as machining one of these. Alright, that took just about 40 minutes. Now, these little studs were originally intended to be cut off after machining, but I realized if I leave them on, I can just throw the whole wheel back in my jig and recut that V-groove at any point in the future, should it get worn out or develop flat spots or something, so I can actually keep reusing those sleeves instead of replacing them every so often like you have to with off-the-shelf POM wheels. I also splurged on some actual machine screws to mount these with, instead of the wood screws I was using up until now, so subtract that from whatever remains of my budget for this project. And at this point, I really just need to drill out the holes in the carriages to an adequate size, tap them, and mount my new V-groove rollers. Alright, moment of truth. Would it have been worth all the effort had I actually machined all these by hand? There's only one way to find out. Not bad in terms of smoothness, even though they're the exact same bearings as before, so it's pretty good. And as far as rigidity goes, OMG, this is insane. If I twist the carriage, it actually bends the rail. I don't know if you can see this, but this is basically what I call rock solid. Just for comparison, this is how much the X-Carriage was able to flex earlier. I think myth confirmed. 2 bearings per wheel, totally worth it, even with the cheapest bearings you can find. That is something I can get behind. Bearings still make the weird clacking noise though. Can anybody tell me why low-grade bearings always make this weird noise? I'm really looking forward to a print bay that maybe doesn't move up and down 0.1 millimeters due to crappy bearings. Also, notice how I removed the Y-axis stepper motor from the carriage. It won't be needed there anymore. Now, one disadvantage of my springy blocks here is that because this screw is cantilevered, the wider my rollers are, the further out the force of the spring has to be applied to the rail, effectively putting a twist into this square section of the block, which results in the wheel being at a slight angle. Certainly not enough to impede functionality in any way, but with these much more rigid wheels, it's certainly worth bearing in mind it'll probably end up wearing down the rails unevenly. Anyway, here it is mounted. I adjusted it to be slightly stiff on purpose, but I cannot find words to describe just how much smoother this runs than before. Listen. Plus, it's actually really rigid. Like, sure, you can deflect it if you push hard enough. It's not made of steel, but that's normal. Honestly, this printer already performs surprisingly well considering just how janky it is, but with these, admittedly no less janky upgrades, I'm confident it'll print like a pro, albeit a bit slow. See what I did there? Also, can I just take a second to complain about how humidity here in the basement over the past year has been so high that these galvanized washers started to rust? My Z-axis stepper motor, rusty. The lead screw inside the plastic sleeve, totally rusted. Heck, look at the state of my screwdriver bits. All the while on the meter, it doesn't even show up as much most of the time. It's as though I had a vat leaking acid fumes in here. Focus, Benjamin. So to mount the X-axis, because those new V-rollers are wider, these individual Z carriages are now ever so slightly closer together, and the existing screw holes don't align with the ones on the axis anymore, meaning I had to plug them, as you can see, in order to drill new ones. I'm also going to attach it with only 2 screws per side now, because my table saw sadly doesn't cut accurate 90 degrees anymore, so there is actually a visible gap on one side if I put the straight edge across both carriages like that. Earlier I had that shimmed, but doing things like that with squishy materials like wood never works out too well. You'll always have tensions trying to twist the carriage, or worse, bend the X-axis. So in order to alleviate that, I'm just gonna have 2 screws straight into the MDF, which should still be plenty strong, but also act more like a pivot, allowing the axis to sit flat against its natural contact patch with the carriage. And to exert more control over that contact patch, I'm actually putting a narrow strip of masking tape across the holes I'm planning to use. That way it can literally tip back and forth on the tape like a seesaw, hopefully preventing me from putting any undue tension on the carriages or the rail. Last but not least, the X-carriage, or printhead, whatever you want to call it. Now, since my original one was super duper custom designed around the fancy gear reduction that came with my stepper motors, and I'm ditching all that crap like I said in episode 15, I made an entirely new one. Dead simple, just 6 pieces of wood, and the extruder goes right here above the hot end in a direct drive configuration. Love it. This is so much better. I wish I could convey the difference in how this feels versus how it felt before, where previously it was a straight motion as long as you didn't touch it, in which case it felt kind of squishy and you knew it was throwing everything off course. Here, I actually have the feeling I have a linear rail in my hand that I can move around without immediately bending everything and throwing everything off course. So this is absolutely amazing, I have to say. And that is where I'm going to call it a day for this episode. Of course, I, again, ended up making a mountain out of a molehill, so I didn't get as much done in this video as I would have liked, which means I'll have to cover installing the lead screws in the next episode. Of course, all of this was a rather pointless exercise just to prove my point. There is really no reason to make your own V-groove rollers, as you'll spend more time making them than the money you save is worth, but nonetheless, it's really good to know that it can be done successfully if you just try hard enough. Collectively, it's kind of easy to forget why things are the way they are, especially for new makers and people just getting into the hobby. Like, to young and foolish me from just 2 years ago, it's not immediately obvious why something is done this way rather than that way, if doing it this way is universally accepted almost like a social norm simply because everyone does it. I don't know why I ever thought a single bearing per V-roller would be sufficient, but now we know. Even though unintentional, my failure to make a $50 3D printer that's actually worth building and owning means with this video series, we now have a public account of why we're building 3D printers the way we are, why we're using NEMA 17 stepper motors, or why we're spending 2 bearings on each POM wheel. Obviously, somebody could have told me all along, "'cause it works better." Duh. Which is totally true, but without actually understanding the reasons behind that, it's just playing expensive Lego to me. Anyway, with all those wisdoms out of the way, I'm really happy with how rigid those new linear rails turned out. Big thanks to PCBWay for sponsoring this episode and saving me a bunch of time machining 16 of these. I'm afraid you'll have to imagine me finishing this one and then doing it 15 more times. Purely in the interest of finishing this video before Christmas, I think cheating was allowed. Exceptionally. That said, special thank you to all my supporters on Patreon. I really hope you enjoyed this partial rebuild, and I'll see you again hopefully soon. Bye bye!